In this video, we're going to be learning about solving linear systems by substitution. There are two different ways of solving linear systems. There's the substitution method, which is primarily used when you have equations in the form of y equals mx plus b. And there's the elimination method, which we'll see in another video. We'll be looking at the substitution method in this video. So here's a general linear systems problem here. This is taken out of the Nelson Mathematics 10 textbook. And I won't read the question, you can read the question. But as you can see here, you have a couple of sentences talking about pool repair. And in both sentences, there is a constant value given here and here for the two different pool services. And there is a rate of change given here and here. And when you have rates of change in constant values, that is usually a sign that you have a y equals mx plus b scenario. So if we write the equations using mnemonic letters, we'll call the first service charge C1 is equal to $40 per hour, which is your rate of change, which has to be next to the letter. Now the letter is going to be representing a time value because $40 per hour changes with respect to time as the lower unit in the rate. Therefore, we're going to use T to represent time, plus the the constant value of $50 for the service call. The second pool company is going to have a charge. Same format, you've got your $45 per hour times the time plus your $30 fee for the service call itself, which is a constant value. So here are your two equations in y equals mx plus b format. We know if we graph these very quickly that C1, which I'm going to use green for, has a higher original cost, therefore is going to be higher up on the y-axis. C2, which has a lower original cost, I'm going to use red for that one, has a lower starting value on the y-axis. Those are your two y-intercepts. But C2 has a higher slope than C1, 45 being the slope for C2, 40 being the slope of C1. So 45, I'm just estimating here, is going to be a slope that looks something like this, and the 40 is going to be a less steep slope. And what happens is we end up with a point of intersection right here. Well, that's what we're trying to find, is what are the coordinates of that point of intersection. It's going to have an x, or in this case a t, and a c coordinate. The x-axis being the t, or the time, and the c being the y-axis, or the charge. So we have to find that point of intersection. Now there's a very quick way of doing that if you have technology and the ability to graph, but we also want to be able to do it algebraically to get a perfect answer no matter what the scenario might be as efficiently as possible. So we're going to use what's called the substitution method. And basically the way the substitution method works, and the reason it works, is because at that point of intersection, we can say that the two y values are equal to each other. And that means we can substitute the equation for the first y value, in this case C1, substitute it into that side of this equation or statement, and we can substitute this one into C2, and we end up with an equation that we can actually solve for t. So it would look like this: 40t plus 50 is equal to 45t plus 30. And now with a little bit of algebra, we can get the t value isolated. So I'm going to subtract the 40t on the right, so we get 45t minus 40t, which is 5t. And I'm going to subtract the 30 on the other side, so we get 50 minus 30, which is 20. using regular algebra rules, that shouldn't be too hard to see. I'm just going to show what we did here. So I brought the 40t over to this side, and I brought the 30 over to that side. Okay. Now we can divide both sides by 5, and we end up with t equals 4, which is the amount of time in hours where both companies would actually charge the same amount. We know before that point, if we go back to the graph, we know that before that point, the red line right here is going to be less expensive than the green one, but after that point, the red line gets more expensive than the green one. So this is where the discussion happens. What kind of answer is this question going to have? Well, it's going to have two answers depending on which side of the point of intersection you are. To find the cost of both companies, you can either use C1 or C2. I'm going to use C1. So C1 is 40t plus 50, and I'm going to substitute the t value that we just found, t is equal to 4, into the equation. So 40 times 4 plus 50. I'll just use another color for that. 40 times 4 is 160 plus 50, which gives us $210 as the cost. So therefore, the point of intersection is 210. And that is basically how you would find the point of intersection. Now we would have a sentence probably that would explain in the context of this problem, at 4 hours, both companies charge $210. I'm not going to get into that at this point. I'm just teaching the proper method of doing the substitution method. We can have different types of questions. This is another question out of the same textbook. It is more based in geometry. Use the diagram and your knowledge of parallelograms to find the values that are indicated. So in geometry, we know that there are different rules for how angles are related to each other in these kinds of shapes. We know that this angle here in a parallelogram is always equal to this angle here, which would actually give us our first equation, 2x plus 4y is equal to 110. And then we also have a couple of other scenarios here that we can use. We know that within one triangle, all of the angles are equal to 180 degrees. So if we look at this triangle right here for the second statement that they gave us, the 5x minus 2y, we can say that the 5x minus 2y is equal to 180 minus 110 and 40. So if I do that up here quickly, we know that the 5x minus 2y is going to give us the answer to that, which I'll write in a second, but just calculating this value, we get 180 minus 150, which is 30 degrees. Therefore, I know that my second statement is 5x minus 2y is equal to 30 degrees. And there might have been another way of coming up with something else. In fact, there is a Z pattern in this, which we could have directly gotten to our equations, but there are multiple ways of doing this. So I wanted to do it this way because I wanted to show how, in this case, we end up with two equations that aren't in y equals mx plus b format. Well, in a case like that, what you'd want to do is isolate y in both if you were going to use a substitution method. So if we take the first equation, which I'm going to call number 1, I'll do number 2 in a second. Taking equation number 1, rewriting it, we can now isolate for y. So we would get 4y is equal to negative 2x plus 110. Oops. And dividing everything by 4 gives us this statement here. And we can simplify those fractions. Which would give us that. Now, this is clearly not a very nice equation, but the nice thing about this is I actually don't have to isolate for the other y value. If this is y, I can now go and substitute that into the second equation. And it's the same idea as the y or the c equals c equation that we did previous, but we didn't have to isolate both of them. Substitution means you can substitute it anywhere. As long as you have a y value in another equation, you can substitute it into that other equation. Now, please note it does have to go in the second equation. You can't resubstitute it back into itself because you'll just get a circular pattern there, which won't help you solve for anything. So we're going to take the green rectangle here and we're going to substitute it into the y of the second equation. So we have 5x minus 2y equals 30. So 5x minus 2y equals 30. And I'm going to substitute the y value that we just got, negative 1/2 x, plus 55 over 2, into that bracket. And in this case, it makes things quite nice because we're multiplying a 2 into the bracket, sorry, a negative 2 into the bracket through distributivity. Well, that negative 2 is going to cancel out the denominators of 2 that are inside of that bracket in this case. That doesn't always happen. Sometimes you get ugly fractions, but here it does work. So we'd have 5x plus 1x, which we'll just write as x because the 2 here and the 2 here cancel. And we'd have negative 2 multiplying 55 over 2, which gives us minus or negative 55, and that all equals 30. Now I can group up by like terms. So 5x plus x is 6x minus 55 is equal to 30. And now I can solve for x with a couple of steps. So bringing the 55 over, we end up with 6x is equal to 85 because the 55 will add to the 30, and x is equal to 85 over 6. And in this case, we didn't get a very nice answer, but that can happen. You would then have to substitute to find your y. I'm going to leave that as an exercise for you to try. You could also, in these questions, have a simply theoretical math question. It doesn't have to be applied. This is just solve this linear system. And in this case, again, you have two linear equations. One of them is in y equals mx plus b. One of them isn't in y equals mx plus b. But we would use the same procedure as we did, sorry about that, in the previous slide, where we would take the y value here, pop it into the y value of the second equation, substitute it in, which is why it's called the substitution method. At that point, you have the ability to solve for x, and you'd be able to solve for the final answer of the x and the y coordinate in the same way that we did before. So that's generally how you use the substitution method to solve equations. In a future video, I'll be showing you how to use the elimination method in order to solve equations that aren't in the y equals mx plus b format. It might be a bit of a more efficient way of doing so.